Hello, my dear students. Welcome back to GIT335, Computer Systems Technology. I again am your instructor, Nicholas Lindquist. Today we will be broaching Chapter 3, Software, Tools for Productivity and Creativity. As we have said before, there are two different types of software, system software and application software, and we will be talking about both of them in detail. So our chapter topics include system software and application software. System software, the power behind the power. As we said before, application software is a specific application to accomplish a specific task on your computer, such as Microsoft Word is a word processing program. Microsoft Excel is a spreadsheet program. Adobe Photoshop is an image editing program. These are all pieces of application software. Whereas system software is the operating system, which tells all those applications and all of the system resources on your computer how to play together in a nice, relaxed, chill environment. So system software runs at the most basic level of the computer and tells the application software how to interact with the computer, etc., etc. So the three basic parts of system software includes, as I said before, the operating system or OS. Some examples of operating systems would be Microsoft XP, which is my favorite version of Windows XP, which is my favorite version of Windows. There's also Windows 7, Windows 8, and then obviously Mac OS X, which is Mac Operating System 10. And each of those, or at least they've stopped doing this now, but they used to be named after kitty cats. So there was Jaguar and Panther, and then Tiger, and then Leopard, and then Snow Leopard, and then Lion, and then I guess they've recently stopped doing that. Maybe they ran out of cats. Anyway, and then on our smartphone devices, we have iOS and Android. And as you know, or may know, there's many different flavors of Android, and those actually have all cute sweets names to them. Like there's honeycomb, and then, I don't know, chocolate, and all these other ones like that. So anyway, operating systems, we've gone over those. Device drivers. And so a device driver is a small file that tells the operating system of your computer how to interface with a particular device that you may have attached to it, or a particular device that may be installed onto your computer. So this happens a lot more with PCs because a PC could have any number of things connected to it. A PC, because it's installed on Windows. This happens a lot more on PCs because those run Windows software. Now a PC could have a motherboard that it's not familiar with, and on that motherboard it might have a modem that it's not familiar with. It doesn't know how to operate that device without the device driver. So the device driver is the interpreter between the hardware and the operating system. So the drivers tell the operating system how to operate a specific type of hardware, which may be something like a graphics tablet, or it might be something internal like a Wi-Fi adapter, or a network card, or a video card, or something like that. So if you connect something and it doesn't work the way you would expect it to, a driver may very well be the problem. Moving on, the third type of system software is a utility program, and a utility program generally supports, enhances, or expands existing computers or programs in a computer system. An example of a utility program would be a disk defragmenter, which clears up extra space that's not being used on your on a hard drive, for instance, or it might be a specific type of utility that perhaps goes and checks the quality of your hard drive to make sure it's doing okay, it's not getting sick, it's not running out of space, it's not doing something like that. So it runs an internal check on some diagnostic part of your computer. Or perhaps the software, like a utility, could also run through and clean up all the fragmented files on your computer. So it could also be used for software or hardware. The operating system, what it does, as I said, it's essentially the traffic cop. In that it directs traffic. It does have other functions as well, and we're going to be talking about those. And the operating system is a low-level manager, but it's not the lowest level. As your computer is first turned on, it first has to do something called boot. You're familiar with the term booting up the computer. So before a computer even boots, it has to pass something called post, which is power on self-test. So if you've ever built a computer before, and I'm willing to bet some of you have, when you press the power button on your computer, the first thing it does is it checks the the RAM to make sure that that's functional, to make sure that there's actually a place to load the operating system into, because it has to load it into RAM in order to fire up the computer. If the RAM is not good, or if the processor is not seated correctly, then it does not pass the power on self-test or post, and your computer will not boot. So after it gets past the post, then we have the BIOS, which is the basic input-output structure of the computer. And even that has to run and tell the computer, hey, good morning, wake up. These are your fingers, these are your toes, this is how you use these things. And then after that loads and passes BIOS, then the operating system itself. So you've probably seen these different levels. When you boot up your computer, sometimes you see a little bit of bloop, bloop, bloop stuff appear before the Microsoft Windows logo. That's the BIOS information. And if you're actually curious about this, it's kind of fun. While that stuff is flying by, if you hit, usually it's F12, sometimes it's the delete key, you can actually get to a menu where you can adjust the BIOS settings that perhaps tinkering with those could affect and improve the way that you interact with your computer. It's worth checking out. Perhaps you've even heard about overclocking a computer or a processor, which is you can actually tell your processor that you want it to run faster than technically it's supposed to run. And sometimes that's safe for the processor and sometimes it's not. But if you have a 3 gigahertz processor, you can choose to overclock it to 4 gigahertz, and perhaps that's okay, it might be too much. Or you could choose to go to 5 gigahertz, should you wish to be very, very, anyway, I'm getting off topic. But anyway, you might want to check out those BIOS settings because it will enhance your understanding of exactly how your computer works. So these things take place before the operating system even steps in and takes over control. But the OS does manage booting. Perhaps you have a dual boot system if you've come to any of the labs here on campus. Interestingly enough, we have 18,000 Macs on across the campuses, which is a lot, and most of those are iMacs. And the reason we have Macs and not PCs is because Macs are capable of booting more than one operating system, because they use Intel architecture on their processors, and that they can load the Mac operating system or the Windows operating system. Boot either of those. So the OS also manages the CPU, central processing unit, file management, task management, and security management. The OS is an extremely, extremely important part of your computer. As we say, booting, I already talked about this, turn the computer on. If it passes post, power on self-test, then we get into BIOS, the basic input-output system. And like I said, that explains to the computer, here are your various parts and here are how they're supposed to work together. Wake up, it's time to get started. Okay, BIOS is good, now let's load the OS and really get going. And then the boot program obtains the operating system and loads it into the RAM, and then from there the computer can actually officially start. That's when you see the Windows logo appear on your screen, or perhaps the Apple. A cold boot is what's known as when you turn your computer on when it is powered off, whereas a warm boot is restarting a computer that's already running. Now, you may or may not be aware of this, but you can boot your computer from other things than just your hard drive. In fact, if you install a new version of Windows, perhaps you're running Windows 7, if you have a Windows 8 boot disk, you insert that into your disk drive, and then on the Mac, you hold down the option button. It will show you the available boot devices, which can include the thumb drive if you have a thumb drive with a bootable disk image on it, or as I said, a DVD, or the internal operating system. So a lot of times there are different options for the OSs that you want to boot up. Or, and this is interesting, you can choose to boot from the cloud. And the way that this is possible on a Mac, if you hold down in while it's booting, it will boot to a network boot if it can find one. And how this is if there is an operating system in a special format available on the network that it knows to connect to, it can boot up that virtual. It doesn't even need any instructions housed on it at all to boot. As I said in a previous lecture, it can be a dumb terminal and just receive the instructions via the network that way. File management. Files are very, very interesting aspects of a computer, in that a file is a collection of data assembled in a certain way with instructions of how that data is supposed to be represented and decoded. So basically all of these things are zeros and ones, but in the same way that a packet we discussed is a header and a payload, a file can be thought of the same way, in that there is a header describing, hey, I'm a JPEG and you should render the zeros and ones following accordingly. and then there's a payload of zeros and ones, which in the case of a JPEG is a map or grid of pixels with color information, hexadecimal zeros and ones defining exactly what each color is inside of each pixel. There are also many other types of files. And I'm sure you're familiar with many of them more than just JPEG. We have .doc for Microsoft Word, .xls for Excel, and .pdf for portable document format. There are many. Moving on, and there are also folders containing these files. And this is the way that all of the files are organized on your computer. Really, on the top level, there's just the C:, and then there's folders with more folders and files inside of that, and more folders and files inside of that, on and on into infinity. It's like a giant tree of files. And the direction to each file is called a path name. And we have direct and relative paths. I guess we don't get into that here. That's okay. Task management. A computer is technically supposed to be able to do more than one thing at a time. And that is called multitasking. But in the same as a human being cannot really do more than one thing at a time, it just tries to do several things at the same time and does them all slightly less effectively. A computer is the exact same way. You can almost kind of think of a computer processor as a much faster version of the bobbin or whatever it's called on a sewing machine. Boom, 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 boom. It can only process one thing at a time, and it can switch off very quickly from one thing to another and make it look like it's effectively processing several things at once. But unless it has more than one physical processor, it cannot do more than one thing at once. It can just create the illusion that it is doing that, and it's actually doing several things a little bit more slowly. So that's why, just like in real life, it's better to keep your mind focused on one thing at a time. Multitasking is necessary sometimes, but if it can be avoided, it should be avoided. Even processors, multi-core processors, you can get a processor with 4 cores or 8 cores. Even then, that processor cannot really do more than one thing at a time. It's just better at pretending that it can. Moving on, other system software. We talked about device drivers and utility programs already. In fact, I already went into this in fairly great detail. Utility is another utility I did not mention. Antivirus software is a critically important utility program. It used to be, perhaps a few years ago, that I would insert a snarky joke here about how Macs don't get viruses, but I can't do that anymore because that's not really the truth. And the reason for that is that the people who write viruses have realized, hey, we can get into Macs too, and now there are a lot more than just 5 or 10% of all the computers attached to the network, the internet, are Macs. And so it's actually worthwhile to write viruses and malware for Macs now because there are ways to get into them and lots of people are using them. Whereas before it was like 95% of the computers on the internet were PCs and they were running old version of Windows. I remember for a little while they used to say that Microsoft XP, if those computers don't get off the internet at some point, they're going to bring down the entire internet because they are so easily accessible and so easy to infect now. And when you get a whole bunch of XP, older legacy operating systems with all of these defense holes together, they're actually called bots, and they become computers that execute other programs that you're completely not aware of. And they form botnets, and they work together. You can get up to 500,000 or 1 million, any number of infected computers, all working together to execute nefarious purposes. Anyway, so that's why utilities like antivirus are critically important. Common features of the user interface. Now, there's different types of interfaces, as I touched on very briefly in a previous lecture. The two basic parts that I want you to be familiar with is the graphic user interface and the command line interface. If you are familiar and comfortable with using a command line interface, almost certainly you don't need to be in this class. So if you are, then you should feel pretty cool right now. Almost everyone else, though, we use graphic user interfaces. But basically, once again, it's almost the same thing in that the graphic user interface just puts a very pretty convenient wrapper with a mouse and a desktop on top of the command line interface. And then that software pretends to be this pretty little backdrop, but in reality, it just transforms those commands into the command line interface that the computer actually understands. So those are the two key different types of interfaces. If someone tells you, oh, GUI, they're not talking about the consistency of their fresh baked chocolate chip cookies. They're actually talking about a graphic user interface. Moving forward, to communicate with graphic user interfaces, we have keyboards and mice. You do not need a keyboard or a mouse to communicate with a command line interface. Features of a graphic user interface: desktop, icons, rollover, menus, all of these things you should already be familiar with. Common operating systems. The platform of the operating system, as we've already said, I listed some of those already. Three principal categories are standalone, network, and embedded operating systems. Standalone are the ones that I have already listed. Mac platforms run Apple Macintosh. PC platforms run Microsoft Windows. And then there's also, as you can see down here in this, right over here, right here. There's a command line interface, and this is what it actually looks like. This is the information your computer is actually receiving when you're operating through the graphical user interface. And then so DOS is a disk operating system, an old one. Perhaps you remember, if you're old and geeky like me, you might actually remember using one of these. Mac OS X 10, I already touched on this. As you can see, there's that cat. I told you, it's all about cats. And then Microsoft Windows. Almost certainly you're familiar with Microsoft Windows, and I don't have to go into that. Network operating systems are a little bit more, are different, obviously. These are more geared towards enterprises. As we said, there's those mainframe computers that are used by corporations, industries, government institutions, that sort of thing, and they would run software programs like this. So this is actually server software, getting servers to work together and respond to requests from client computers. So yes, here we go. Used for coordinating local area networks, groups of other computers through a company or campus or corporation, whatever it may be. The network OS located on a main server is kind of like what I was just describing to you. A network boot would be the computer is a dumb terminal, and it loads the network operating system into its memory and boots that. It's not internal to it. Windows Server is software for servers, basically. We don't need to talk too much about that. Unix. Unix is interesting in that Mac actually runs on Unix, and Unix is a very, very sturdy platform that the Mac operating system converts into Unix commands to execute the instructions. But it says here that Unix is a multitasking operating system with multiple users that has built-in networking capability and versions for all kinds of computers. It's an older operating system. It's very, very, very secure. And Mac was actually considered very secure because it ran on Unix. Let's see here. Continuing on, the Unix interface is a command line interface. As I said, the GUI communicates with the command line to give the instructions to the computer. Linux is a free version of Unix. Now, one reason that I am actually very partial to Linux and other open source software is that it is extremely secure because it is open source. Now, the difference is Microsoft Windows is not open source, and that the source code that the Microsoft Windows source code is closed source. It is compiled. It is a bunch of basically code that I don't even want to imagine how terrible that code must be. And then it is compiled into source code that is closed, proprietary. And so therefore Microsoft alone are the ones who are required for running the updates for it. So when people find hacks for Microsoft Windows, only Microsoft can respond to it because they're the only ones who know about the code inside of themselves, inside of Windows. But Linux is open source in that you can go and download that software and you can make alterations to the code, and you can even submit it, and it can be bundled and included with a future version of Linux. And for that reason, it's much, much, much more secure, and that the software that constitutes it, the code that constitutes it, is public domain. So Mozilla Firefox as a browser is also open source, and for that reason, supposedly, it is more secure in that it is also open source. Moving forward, embedded operating systems are embedded onto the computer operating central processing unit chip. Embedded means that, as you can see here, there's a memory chip actually embedded onto that device. And should those instructions that have been embedded onto that chip become corrupt for whatever reason, that device will stop working. And that's actually one of the reasons that they say that your motherboard, any piece of electrical hardware like that, should it get zapped by any kind of electrical current, it would lose those instructions and then become completely worthless to you. So that is an embedded software, embedded operating system. Application software. There's a lot less to say about application software, but I should also remind you, I did remove some of the PowerPoint slides from this presentation. There will be many, 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 many more slides that you will need to review in order to be completely prepared for the quiz on this material. So you will need to download and become familiar with the PowerPoint slides. Just because they're not in the lecture doesn't mean that you will not be quizzed on them. However, all the material on the PowerPoint slides can be found in the textbook. So while it is not strictly necessary to study the PowerPoint slides, if you are familiar with the textbook, it is a good synthesis of the things that are most important. Moving forward, people interact with the application software. And as I've said, the examples I've been giving are Microsoft Word, Microsoft Excel, Adobe Photoshop, etc. So here are different types of files. We have the graphic files, JPEG, GIF, PNG, ones like that. Audio files, MP3, MP4, other file types such as those. Video files, AVI, MP4, M4V, MOV are all different video file types. If you're what's the one that I absolutely hate? I'm going blank on it right now. There's one specifically for Windows that I absolutely hate to get. Oh, WMV. Yes, my TA has just reminded me that the WMV file is the one that I can't stand because I'm very Mac, and Mac does not like WMV files. And then there's many, 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 many other file types. Some of those file types are program files. As I said before, those are different types of files that are supposed to work with different applications, different programs. And then there's source program files that contain high-level computer instructions in the form written by the computer programmer. And the best example of this is .java, as I'm sure you've heard of Java. And then there's executable files, and these are the ones that are most likely to be nefarious, and that .exe files, .executable, when you double-click on them, they execute some sort of process, some kind of executable process on your computer that may or may not be malicious. But exe files are also installation files. So if you don't know the source, it's better to not run exe files. Data compression is interesting. I try to get my mind around exactly how it works, and unfortunately that does go over my head. How do you archive a file to where it contains so many less zeros and ones, but then you unpack it again and it contains the same amount of zeros and ones? There must be some kind of algorithms involved in compressing and then archiving and then unarchiving those files. But in any case, that is what data compression is. If you archive a file, like a zip file is a perfect example, it compresses it to a much smaller file size, and then when you double click it again, it unzips that file. It's interesting to wonder, how exactly is it possible to do that? There must be some kind of algorithm that goes over my head in this case. If you can figure it out, email me and I will give you 5 extra credit points. So anyway, lossless is during that process, sometimes bits are lost. So lossless ones obviously do not lose those precious bits and bytes when they are compressed and decompressed. And other files are lossy, and the best example I have for this is like a JPEG is a lossy file type, and I can explain why. If you have a JPEG that is 100 pixels by 100 pixels, let's say that you then decrease that file size to where it shrinks down to 10 by 10 pixels. All of those are lost, those zeros and ones. So then you decide again, well, you know what, this looked better at 100 by 100, and you blow it back up. All of those pixels, all of that data describing the colors of those pixels has been lost. And that picture will never look as good again because the computer will attempt to use its best judgment to fill those pixels that have been lost, and it will just not look good. So surely you've seen those pictures on the web that are blown up. The rule of thumb is to never blow up a JPEG more than twice what it's more than 200%, because then the computer will have to use its best judgment, and computers are not especially good at that. But anyway, JPEGs are lossy for that reason. So continuing on a little bit about common graphic file formats, as I said, JPEGs are on here. We also have bitmap, GIF files, TIFF files, and PNG files, and they each have their own positives and negatives. As you may know, a GIF format supports transparency. It also supports animation, in that you can see a series of images that create a short animation. Also, a JPEG cannot have transparency, so it will always be either a rectangle or a square, whereas a GIF can be cut out and you can have those transparent pixels. However, GIFs are a larger file size, and the JPEG is a more compressed, smaller file size. TIFF is a file type that you will probably not be using unless you're dealing with high resolution, high quality images. So if you were designing a poster design, say, if you were designing a poster that needed to be very high resolution, very high quality, you would want to submit it as a TIFF, because that would be the absolute highest quality you could get. None of those pixels or color data would be lost. However, the file size would be rather extreme. Whereas a JPEG of the same would be a lower quality and much lower file size. And then PNG, Portable Network Graphic, is an alternative to GIF, which is becoming a lot more common. Video editing software, some examples are Adobe Premiere, which is the software I use to edit these lectures. Final Cut Express. Audio editing software, a free one that I like very much is Audacity, and you can get that at, I believe, sourceforge.com. And that concludes the third lecture on System and Application Software. Thank you for your attention, and I will see you next time for Computer Hardware, Chapter 4.